So welcome back to the online classes. In the live interaction, we had discussed about the rate expressions and the numericals. Now, today we are going to discuss such a topic known as collision theory. It is a little bit different from the topic that we had already discussed, because the topics that we had discussed there, we were having mathematical output everywhere. But in this case, the mathematical expression is very less, calculation is less, concept is more. So the collision theory, it is actually, you can say, it is the energy and orientation barrier to the reaction. So we are going to discuss the energy and orientation barrier to the reaction. As I have told you, it is mostly conceptual. So we are going to discuss about concepts mostly. See, whenever the reaction happens, during the time of reaction, what is more important? The reactant particles, suppose A and B, combining with each other to give rise to product. Here the important thing is that the molecules of A and B will actually come in contact with each other, and therefore it will give rise to products. But it is not so simple as it seems. There are various factors. First of all, why is that they are going to come in contact? We know that when the molecules are kept, the molecules will have some kind of collision in between them, because they are moving around. There must be in a motion. So if the molecules are coming in contact with each other, then only the product is possible. So in order to do that, the collision must be there. So first thing is, the requirement is collision. That means the reacting species must come in contact with each other. Next is collision frequency. And then we will discuss about energy barrier. So let us discuss about these three things first. First is collision. That means the reacting species must collide with each other. Next is the collision frequency. We can define it as number of collision per unit time, or you can say per second, per unit volume. So this is called the collision frequency. That means the number of collision per second per unit volume. And there is another thing called energy barrier. So let me discuss about the collision frequency first. It is actually defined as Z. So in collision frequency, it is quite obvious that if number of collision increases, then obviously if the total number of collision increases, the chances of the molecules to come in contact with each other will also increase. So obviously if the number of collision increases, suppose earlier it was 10, now it is 100. So per second per unit volume, the collision frequency automatically will increase. So if the number of collision increases, Z also increases. How can we increase the number of collision? If we increase the temperature, if temperature is increased, you must have seen that in the kinetic theory of gas, that if you increase the temperature, the molecules will move around faster. So there is a chance of more number of collision. So collision frequency, or the Z value, will also be higher. But at the same point of time, we must also look into another factor known as effective collision. It is regarded as F, the effective collision. Now, what is effective collision? It means that all the collisions among the reacting species at a given temperature are not effective in bringing about the chemical reaction. The collision which actually produces the product are known as effective collision. Suppose there are 10,000 collisions takes place. So obviously that all of them are not effective. Maybe out of those 10,000 collisions, only say 100 collisions are effective. So these are called, only these 100 collisions are going to give rise to product. Rest of them are not giving rise to product. The molecules are colliding but not giving rise to product. So only the collision which gives rise to product is known as effective collision. Okay, so this is about the effective collision. Now let us see how can we get these effective collisions, because that is more important. Number of collision is important, but more important is what is the number of effective collision. So to find it out, effective collisions basically depends on two factors. So now we are going to talk about the effective collisions. So we can say that this effective collision depends on two factors. The factors are energy barrier and orientation barrier. So energy barrier and orientation barrier. What is the energy barrier? Remember, for a reaction to take place, each molecule must possess a particular amount of energy. That energy must be supplied. So we can say for a reaction to happen, each molecule must possess a particular amount of energy. Now the next point is orientation barrier. What is orientation barrier? Orientation barrier means, if I give you the example of this pen and the cap, suppose these two are combining and is giving rise to this product. So the collision means between the cap and the pen, there can be various kind of collisions. It can come like this, it can come like this, it can come like that. But out of those hundreds of collisions, only when it will come like this, then only the product will take place. So reactions are also like that. For example, in order to understand the orientation barrier, a very good example is the SN2 reaction. Suppose we have this one, CH3Br. Okay, now OH minus is coming. For an example, OH minus, it is coming. So there are various ways. It can come like this, it can come like this, it can come like this also. Various ways. But out of all these ways, only when it comes exactly from behind, then only the bromine is removed and it gives rise to the formation of CH3OH. So the correct orientation is important. The correct way of approaching is important. So that is called the orientation barrier. must maintain the required orientation during collision. Otherwise, there will be ineffective collision. So what we have seen the two cases initially. One is the collision frequency and another is the effective collision. In order to have the effective collision, these two energy barriers, these two factors are important: energy barrier and orientation barrier. So if we want to sum up the collision theory, it will be like this. For a reaction to occur, there must be collision. So if we sum up, it will be like this. For reaction to occur, the collision must be there. Collision must be there. Next is, out of all those collisions, only few of those collisions are called effective collisions. Effective ones, very, very important. And in order to have the effective collisions, there are two factors. One is energy barrier. They must maintain the energy barrier, and they must be following the orientation barrier. So further, as we know that if we express this, suppose we express this as rate. So rate of a reaction, suppose A plus B giving rise to product. In this case, the rate can be written as minus dx by dt is equal to F into Z. F into Z. So this is how the collision theory is expressed. This is all about it. If the question comes, mostly it will be having 3 marks. You must write down these equations, you must sum it up, and you must be knowing the nitty-gritty of the basic things of the collision theory. No mathematical outcome as such apart from this particular equation. So you need to understand what is basically happening. The molecules must collide, the collision must take place, and not any collision will give rise to product. Only particular effective collisions will give rise to product, and the effective collision must have energy barrier and orientation barrier. So both the terms, the number of collision, that means the collision frequency, and also the effective collisions, both are important. So that is what we have written down in the final equation.